angle from radians to degrees, we multiply by pi over 180. So let's start with 30 degrees. To convert 30 degrees to radians, we're going to multiply 30 times pi over 180, which gives us 30 pi over 180. And as we know, if we have a common factor for both 30 and 180, we're going to simplify it. The common factor for 30 and 180 is simply 30. 30 goes into 30 one time, so that would be just 1 pi at the top. And 30 goes into 180, 3, 6, 9, 12, 15, 18, that's 6 times. So kind of by 3, but it's the same as kind of by 30. So 30, 60, 90, 120, 150, 180. So 30 degrees converted to radians is pi over 6. Let's do the next one. 45 degrees. We multiply 45 by pi over 180. And that's going to give us 45 pi over 180. And the common factor of 45 and 180 is, you guessed it, 45. 45 goes into both the numerator and the denominator evenly. 45 goes into 45 once, so we got 1 pi at the top. And 45 goes into 180 4 times. Next one, 60. 60 times pi over 180 is 60 pi over 180, which can be reduced because 60 and 180 has a common factor of 60. 60 goes into 60 once, so that's 1 pi at the top. And 60 goes into 180 3 times. 60, 120, 180. So we need 3 as our denominator. Here we go. 90 converted to radians is equal to 90 pi over 180. And 90 and 180 have a common factor. The greatest common factor of 90 and 180 is 90. 90 goes into 90 once, so our numerator is going to be 1 pi. And 90 goes into 180 twice, so our denominator is going to be 2. Let's keep going. Great job, everyone. 120 converted to radians is going to be 120 pi over 180. The greatest common factor of these two numbers is 60. So we're going to divide both our numerator and our denominator by 60. 60 goes into 120 2 times. So we're going to have 2 pi. And 60 goes into 180 3 times. So our denominator is 3. Next one, 135. 135 converted to radians is going to be 135 pi over 180. And the greatest common factor of 135 and 180 is 45, which puts us, 45 goes into 135 3 times. 45, 90, 135. So we have 3 pi. And 45 goes into 180 4 times. 45, 90, 135, 180. The next is 150 degrees. 150 degrees converted to radians is equal to 150 pi over 180. The greatest common factor of 150 and 180 is 30 degrees. 30 goes into 150 5 times. So that's 5 pi. And 30 goes into 180 6 times. So if we count by 30, 30, 60, 90, 120, 150, that's 5 times. And then 180, that's 6 times. Our next number, or our next measure of degree, is 180 degrees. 180 degrees converted to radians is 180 over 180 pi over 180. Our greatest common factor between 180 and 180 is, of course, 180. So we divide both the numerator and the denominator by 180, and we're just going to end up with pi. The next number, the next measure of degree is 210 degrees. So 210 degrees as a radian is 210 pi over 180. Which can be reduced because they both have a common factor of 30 degrees. Our greatest common factor is 30 degrees. So 30 goes into 210, 30, 60, 90, 120, 150, 180, 210. That's 7 times. So we'll give us 7 pi as our numerator. And 30 goes into 180 6 times. Our next angle, our next degree of measure is 225 degrees. And 225 degrees as a radian is 225 pi over 180. Which can be reduced because both the numerator and denominator have a factor of 45, which is our greatest common factor. 45 goes into 225 how many times? So let's see. 45, 90, 135, 180, 225. 45 goes into 225 5 times. And 45 goes into 180 4 times. Let's keep going. 240 degrees as a radian, converted to radians, is 240 pi over 180. Which has a greatest common factor of 30 degrees. Well, actually, it has a greatest common factor of 60 degrees. 30 degrees is also a factor, but the greatest common factor is 60. So 60 goes into 240. Let's see. 60, 120, 180, 240. So 60 goes into 240 4 times. So our numerator will be 4 pi. And it goes into 180 3 times. 270 as a radian, 270 degrees as a radian, is 270 pi over 180. Which can be reduced by finding the greatest common factor, and in this instance is 30. 30 goes into 270 9 times, so our numerator will be 9 pi, And our denominator will be 30 goes into 180 6 times. Something there is off because this should still be reduced. There's a common factor of 3. 3 goes into 9 3 times. So that's 3 pi over 2. So really we should have reduced by 60. If we would have reduced by 60, we would have just ended up with this answer here. Because 60 no, wouldn't have been 60, it would have been 90. 9 goes into 270 3 times, and 9 goes into 180 2 times. So 90 is the greatest common factor of 270 and 180. 300 degrees converted to radians is 300 pi over 180. Which can be reduced by finding the greatest common factor. In this instance, the greatest common factor is 60. 60 goes into 305 times. So it's going to be 5 pi. 60 goes into 180 3 times. Our next degree of measure is 315. As a radian, it will be 315 pi over 180 degrees. Which has a greatest common factor of 45. So 45, 90, 225, 180, 315. No, not 315. It's going to be 270, then 315. So 45, 90. 135, 180. 225, 270, 315. So that was 7 times. Well, 45 goes into 180 4 times. Next one, 330 is equal to 330 pi over 180. Our greatest common factor here is 30. 30 goes into 330 11 times. Yep, 30 goes into 300 10 times. So 30 goes into 330 11 times. And 30 goes into 180 6 times. Then our final one, 360 degrees is equal to 360 pi over 180. And the greatest common factor of 360 and 180 is 180. 180 goes into 360 2 times, 180 goes into 180 once. So our answer is simply 2 pi. Great job, everyone.